Section 9.5 deals with points of intersection. So we're talking about points of intersection between two straight lines, or the line and a plane, as well. So let's have a look at how to find a point of intersection between two lines, if it exists. So you could actually have two lines in space that are parallel to each other and then don't have a point of intersection. You can also have non-parallel lines that do not have point of intersection. They're called skew lines. So for example, one going like this, one going like this. They will never meet, if you could see. They're not parallel, but they will never meet. Okay, so they are called skew lines. So, but in example 22, we are told that these two lines do intersect, and need to first of all show that they intersect. If the question asks you to show that the two lines intersect, you need to be really careful and make sure you are thorough. So if they intersect, we are going to, in order to find the point of intersection, but first of all to show that they intersect, we're going to make L1 equal to L2. Now you don't get any marks for just writing something like this. You're going to, I prefer to write it as a column vector. So my L1 is 3, 1, 1 plus lambda 1 minus 2 minus 1. And I'm going to make it equal to L2, which has equation minus 0, 3 plus mu minus 5, 1, 4. So we're going to making the two lines equal to each other, we are going to generate three equations. So the first one is 3 plus lambda is equal to minus 5 mu. The second one, minus 2 lambda, is minus 2 plus mu. And the third one is 1 minus lambda is equal to 3 plus 4 mu. So if I name these I, and I, I'm going to use the equations, the first two equations. You can pick any two equations to solve them simultaneously. So use those two to solve simultaneous equations. So this one will give me lambda is equal to minus 5 mu minus 3, and I'm going to substitute it into the second one to obtain 1 minus 2 lambda is equal to minus 2 minus 5 mu minus 3. So 3 mu is equal to, oh, what have I done? Let's try again. Sorry, I've substituted in lambda in terms of into mu. Let's try again. Didn't make sense. Minus 2 plus mu. There you go. So you've got 1 plus 10 mu plus 6 is equal to minus 2 plus mu. That gives me 9 mu is equal to minus 9. So mu is equal to minus 1. That's a nice answer. So lambda is going to equal to minus 5 times minus 1 minus 3, which gives me 5 minus 3, which is 2. Now, you don't need, if you're just finding point of intersection without proving it, you just need either mu or lambda, and you substitute. If you find mu, you substitute into this one to find the point of intersection. If you found lambda, you substitute into this one. Because we are proving that the point of intersection exists, we've got to find both, and now use lambda equal 2 and mu equals minus 1 in the third equation to prove that it agrees. So the left hand side is going to be 1 minus 2, which is minus 1. The right hand side, that gives me 3 plus 4 times minus 1, which is minus 1. So minus 1 is equal to minus 1. So agree and the line L1 and L2 intersect. So point of intersection, therefore, either use L1 equation or L2. So I'm going to do L1. So lambda is equal to 2, so it's going to be 3 plus 2, and then 1 minus 2 times 2, and then 1 minus 2 as the coordinates. So write it horizontally. It's 5 minus 3 and minus 1. So that will take us to, oh, there's 2 more examples. Okay, so let's have a go at another example 20. Example 23, we've got a straight line with the following equation, and we've got equation of a plane, so line L and plane pi. And we are asked to find the coordinates of the point of intersection of that line. So what we're going to do, we are going to write the general point of the straight line in terms of its vector. So r is going to be equal, let's put it all together. So it's minus 1, 1 minus 5, and then you've got plus lambda, 1 lambda, and 1 lambda again, and then 2 lambda. And we are going to substitute this into this equation, which is your r dotted together with 1, 2, 3 equals to 4. So substitute it instead of r. So we are going to get minus 1 plus lambda, 1 plus lambda, minus 5 plus 2 lambda. Let's dot it together with 1, 2, 3 and make it equal to 4. So let's do the dot product. So multiplying the by 1, the top element. So it's going to be minus 1 plus lambda multiplied by 1 plus 1 plus lambda multiplied by 2 plus minus 5 plus 2 lambda multiplied by 3. This is equal to 4. So you've got minus 1 plus lambda plus 2 plus 2 lambda minus 15 plus 6 lambda is equal to 4. That will give me 8, 9 lambda. Then you've got 1 and then minus 14 onto the other side. That gives me 18. Giving me lambda is equal to 2. Now that finds me the value of lambda that now I can substitute into the equation of my straight line to get the coordinates. Now remember, I've put this together, vector general of the general point on the straight line, or the vector equation could be written like this as well. So we're going to substitute lambda equal to obtain the coordinates. I'll write them horizontally straight away. So it's minus 1 plus 2, 1 plus 2, minus 5 plus 2 times 2. So that gives me 1, 3, and then minus 1. Perfect. Now, example 24, here's a straight line, Cartesian equation is given. A note here, this is over 1, so the direction vector is 4, 2, 1, and the point on the line is 2 minus 3 plus 1. And here's another line, and we are going to show that these two lines do not intersect. In fact, that they are skew. Now they could be parallel and not intersect, but you could see that this one has 4, 2, 1, and this one has 5, 4, minus 2 as the direction vector, so they're not multiples of each other. So what we're going to do is rewrite our L1 and L2 in terms of its vector equation. So r is equal to, remember, you take the opposite values of those numbers in the numerator, so it's 2 minus 3, 1, plus, let's choose lambda 4, 2, 1. And then L2 is going to be R equals to -1, 0, 4 plus mu, and then 5, 4, -2. We're going to make them equal to each other, and we're going to do, at least at the start, attempt to find the point of intersection, so make them equal to each other and fail. So let's do that. So putting these together, L1 is going to be 2 plus 4 lambda minus 3 plus 2 lambda, and then 1 plus lambda. And then from this equation, you are going to get -1 plus 5 mu, and then 4 mu, and 4 minus 2 mu. So let's use two equations from the top, the first top equations, to solve them simultaneously. So let's just do it a bit quicker. 4, okay, let's have 4 lambda is equal to -3 plus 5 mu, and here I've got 2 lambda is equal to 3 plus 4 mu. So if I times that by 2, I'll have 4 lambda is equal to 6 plus 8 mu. So what we're going to do is eliminate them, so subtract them. So 4 lambda minus 4 lambda, that gives me 0 lambda, minus, remember I'm just taking this one and this one into account. I mean, you choose your own method, I just picked that method. -9, and then 5 take away is -3 mu. That gives me mu is equal to -3. Now, how am I going to show that it doesn't work? Well, I'm going to now do what I would do if I was proving that they intersect. So sub into sorry, I need to sub it as soon as I found the lambda. Lambda here is going to be, well, lambda is 3 plus 4 mu over 2 from this equation. So if I put -3 into this, that will give me, is that going to be -3? Let's just check. 3 minus 12. That's right, 3 minus 12 with minus. Oh, okay, it's not going to be quite that. Just do it slowly. 3 minus 12 over 2. That gives me -9 over 2. So let's put these two into our third equation. So on the left hand side, I'll have 1 plus -9 over 2, which is -7 over 2. On the right hand side, I'm going to get 4 minus 2 times -9 over 2. So that's going to be 4 plus 9, which is 13. So left hand side is not equal to the right hand side. So they do not intersect. But just because I've shown that they do not intersect, it does not prove that they are skewed. So far I've proven that they do not intersect. What shows that they are skewed is we need to have a look at the direction. So direction vectors are, so D1 from the line L1. So let's have a look. So this one here is going to be 4, 2, 1. From L2, your D2, that was 5, 4 minus 2. 4 minus 2. That's correct. Okay, so D1 is not parallel with D2 as they are not scalar or just multiples of each other. Okay, so for example, to get from 2 to 4, I would have to double it, but if I double 4, I don't get 5, and if I double 1, I don't get -2. So the lines are skew. So if you forget to consider the direction vectors, you're not getting full marks for that, you're losing a couple of marks possibly. Okay, so you can go on to exercise 9E.